I'm going to introduce Hariam Zitsat, and he's going to be talking about reinforcement learning interpretability applications to algorithmic trading, which goes with everything that was just talked about. Please take it away.
Good afternoon, everybody. I hope there's some energy left at the end of the day. So my name is Hariom. I work for Barclays as a VP. I'm also author of this book called Machine Learning Data Science Blueprint for Finance. And the topic is reinforcement learning interpretability in the context of algorithmic trading. So reinforcement learning interpretability, all these are buzzwords. We have heard about it today as well a couple of times. But more than like thinking about these as buzzwords, our focus was to use this in understanding what happens inside like a model which is trained on reinforcement learning in the context of algorithmic trading. So, for example, if you are a trader or if you are a strategist, you're making all these machine learning models for algorithmic trading, and you go to the investor, you ask them, or you mention them that, hey, my model is making so much amount of money in the back testing. The first question that they will ask is, why? Why it is making so much money? What are the drivers, and what's the intuition behind it? And that's what we are trying to solve, or that's what we are trying to go towards in this project. Just as a disclaimer, this is not a part of my work that I do at Barclays. This is something I collaborated with Lehigh University, Masters in Financial Engineering program. And there were a bunch of great people, great students, and they worked on this. We got a paper published, and it was doing pretty well. Okay, in terms of agenda, it's slightly away from what we have discussed today on LMM and all. It's more core finance. I'll be talking about reinforcement learning for algorithmic trading, how it is being used, how is it different from the conventional type of algorithms that we have been using in algorithmic trading. I'll also be talking about interpretability, why it is important in finance, how is it different, what are the challenges for reinforcement learning. Then I'll be talking about the reinforcement learning setup, the entire setup that we had, followed by the work that we did, which was the interpretability model that we built. So the first few minutes, the first 10 minutes, the focus would be just going in, doing the introduction, and then I'll be talking about the meat of the product or the meat of the session. The core of the session is the interpretability approach. And it's not very quantitative as such. It's more like doing enhanced or advanced data exploration. But sometimes the simple stuff works better than the complex stuff, right? And finally, takeaways and the questions. So this was basically the paper that we got published. You have the link and everything in case you want to refer to. And let's move to, okay. So reinforcement learning, most of you might be aware of what is it. You maximize rewards and minimize the losses. And you learn by experience, basically. And why it fits perfectly to the financial use case, because if you think about trading, if you think about portfolio management, what you're basically doing is trying to maximize the reward and minimize your losses, right? So this was something which was used in AlphaGo. This is something which is used in ChatGPT, RLHF. We heard about it quite a lot of times. So when you talk about trading, and there are a lot of machine learning models which are being used in trading, supervised, unsupervised, reinforcement learning, and whatnot. So in supervised learning, what we are doing is we are predicting. We are saying, hey, what's the price of Apple tomorrow? And then we are making some rules after that. So if the price goes above 2 standard deviation, 3 standard deviation, we'll buy, sell, so on and so forth. Now, reinforcement learning, we are not doing any of that. It's pretty much like a trade bot. You have a trading bot. You have a box. You train it with some data. It does some prediction. It takes an action, buy, sell, hold, and that's what you deploy. The good thing is it's completely automated. The flip side of it is the word that we have been talking quite a lot, interpretability. Right? So it's less interpretable because you don't know what kind of strategy you're applying, whether you're doing momentum strategy, mean reversion strategy, whatnot, right? Now, need for interpretability, this is something very obvious that I just put, why interpretability is really important in finance, because you have money and reputation at risk. Right? Small error, small issue, can cause big problems, something we have seen in form of subprime crisis. Even if you think about like the model that crashed or the model that created problem in the subprime crisis was like CDO model. Maybe we didn't understand it pretty well, and that's why it's very important to understand the models in context of finance. And why interpretability is important, because another point is something I mentioned in the beginning. If you're trying to sell a model to an investor, let's say even if it's, let's say, credit scoring model or a loan default model, unless and until you can answer the question why, you won't be able to sell it. You won't be able to pitch it to anyone, right? So that's why interpretability is pretty important. Why it is difficult in case of reinforcement learning, right? So in supervised learning, you have a prediction. You say that, hey, the Apple price tomorrow is dependent on price to earning ratio of Apple price, right? 50% of the prediction is coming because of this price to earning ratio. That is something you can't do in reinforcement learning because there is no labeled output. And on top of that, the reinforcement learning models are extremely complicated in the sense that they have a lot of parameters, hyperparameters, and the model architecture I'll just be talking about. It's really, really complicated. I mean, you have neural networks, number of layers, and whatnot, right? So digging down deeper into those, understanding neurons and whatnot is extremely difficult. Now, coming to the setup that we had, how did we train and how did we create the reinforcement learning model? So these are some of the high-level bullet points. The security that we had was S&P 500. The training period was 2015 to 2018. Some of the features that we use. So features are basically the input that goes into the model. We use price and volume. And this can be as complicated as possible. It can be sentiments. It can be your fundamental features and whatnot. The reward function that we use was Sharpe ratio. So what is reward function? That's something you're trying to maximize, basically. That's the problem statement you give to the algorithm that, hey, why don't you maximize my Sharpe ratio? And that is what it does in the background. And the model that we use was deep Q learning. That's something I'll talk about later. So this is basically the model training. So how does it train? It trains pretty much how we as humans train ourselves. We maximize reward, minimize punishments or the losses, right? So what's happening here, if you see the chart, there's this Q thing that's called Q table. So you feed in the data to the algorithm. It takes some action on the basis of whatever it has trained so far. And on the basis of the reward, so let's say it made some profit or made some loss. On the basis of reward, it goes back and trains its Q table. Q table you can think of as like trader's brain. So the brain is what you're training, right? Which is pretty much represented by that neural network that's shown in the bottom. So what that neural network does, it maps your state to action. What's the state? What's the price change? What's the volume change? So these are the state. And the action would be buy, sell, or hold, right? And that's represented by a neural network, multiple states, multiple action. And that's eventually is getting trained. After the training set or after the training, you end up with a really good neural network, or you think you end up with a really good neural network, which we can use for further training. Now, when we trained the model, we found few interesting stuff. I mean, the pictures are pretty small, but with the iterations or with the episodes, as we had more and more episodes, what we saw was that the algorithm was making some money. So in the first few episodes or the first few iterations, it was losing money, and those points are like buy signals and sell signals, the triangle that you see. The purple one, I guess, are the sell, and the red ones are the buy. And what was happening was in the first few iterations, the buy and sell signals were not very intuitive. It was buying at some random period and selling at some random time period. Now, when we trained it more and more and more, what we realized was, or what we found was, the patterns were becoming more intuitive, and also the profit, the amount of money the algorithm was making, was increasing, which was pretty intuitive. And then we put the same model in the test set, or we try to, after training the model, we try to test it with some test data. We ended up having a profit. There was some decent money that we made. And the buy and sell signals were also sort of intuitive, not very intuitive, but yeah, I mean, it was at times buying at low price, selling at high price, so on and so forth. Okay, so do we stop here? I don't think so. Why? Because the key questions that I mentioned in the beginning, I mean, these are not asked, not answered by just looking at the buy, sell, or the profit. What are the drivers? Does it resemble any other algorithmic trading strategies that we have seen before? Momentum, mean reversion, whatnot. You don't have an answer to that. What's the impact of the hyperparameter changes? So these are the questions that will be very important for you if you are, let's say, quant, you're designing these strategies. So the first two are basically the questions that investors will ask or the portfolio managers will ask. The last few are more from a quant point of view, that what will be the impact of all the hyperparameter changes? Is there some overfitting happening? And the bigger question is that can results be trusted for making the trading decision? That's like $1 million question that you have in case of algorithmic trading. So how did we try to solve it? Again, it was not a very quantitative approach. It was sort of qualitative or advanced data exploration, I would say. But these are the questions that we tried to answer. That what might be the drivers, whether it resemble any algorithmic trading strategy, momentum, mean reversion. Can we find some pattern? Can we dig deeper into it? Whether algorithm is stable or not, it might be doing something random. You don't know, although it's making money, but there might be some random or unstable behavior it might be doing. What's the impact of the hyperparameter is next question. So what we did was we built some kind of infrastructure, or you call it like dashboard, which leverages the data exploration and visualization. You can vary hyperparameters and check the impact, and you can also deep dive into the training and the testing process. Right. So essentially, what we are trying to do is we are trying to dissect and understand the algorithm while it's doing training and while it's doing testing. So this is just a pictorial representation of what I just mentioned. So when you are in training, you look into what's happening within an episode. Episode is an iteration, and iteration of the training set. And what's happening between two episodes is what you check. In the testing phase, you check the action and state heat map. I'll describe it in more detail. So although, I mean, the size of the dashboard is pretty small, but what's happening here is the core of this slide is the heat map. What we are trying to do is, on the x-axis, it shows price change. On the y-axis, it shows the volume change. And you see whether it's doing buy, sell, or hold by different color, right? So buy is green, sell would be red, and so on and so forth, right? So how or what information you can get out of it. And before we go into that, I mean, there are a couple of other things that we have on this. We have on the left side, we have the hyperparameters. You can change all these hyperparameters. You can vary the test or training set. You are loading the model, and you are trying to run this or get this heat map while you're training or testing. So what is the interpretability out of it? So with this, if you see some pattern, whether there is some pattern of volume and price, if the volume is decreasing and the price is also going down, the algorithm is just doing buy or algorithm is just doing sell. So that's something you can figure out if there is some intuitive training pattern. You can also check whether it resembles any trading strategy. You can check whether it resembles like momentum or mean reversion and whatnot. And you can also see the hyperparameter impact. Like if you vary the hyperparameters, what's happening to this heat map, whether it's becoming more intuitive, less intuitive. And there's just one example I have. So we tested it with increasing the number of layers in the deep neural network, pretty basic stuff. And when we increased the number of layers to quite a lot, what we figured out was it was becoming like pretty weird. I mean, it shows red, which means it was just selling. It was not even buying. It was very, very unintuitive. So these kind of analysis or these kind of results can help you in dissecting, understanding what's happening inside the algorithm. You can definitely check for whether there are some anomalies, whether it's stable, whether it's overfitting. Then there was this inter episode within an episode. So you're training it. There are different iterations that you have. We checked between, let's say, 10 iterations, what's happening in terms of buy and sell. So these three lines represents buy, sell, and hold. If these are pretty volatile, which means that it's unstable, it's taking some random decisions, it's not converging as such. And just to clarify a little bit more, the the y-axis shows the action, and the x-axis shows the episodes. But yeah, I mean, the conclusion here was that it's pretty volatile. And after this, we trained it with some more episodes, with some more steps, and then it kind of converged. It kind of became slightly better in terms of those lines that we are seeing. And the next thing was like intra-episode. What's happening for a given episode? What's the buy, sell, and hold? And this is where it kind of be interesting. This is where it can be intuitive. You can maybe link it to the macroeconomic variable. Maybe you can link it to the news. So what we observed was that in February of 2018, when there was US-China tension happening, then the algorithm was doing buy, and it was learning all by itself. We didn't train it to do so. It was learning all by itself. And when we went to the next episode, when we trained it a little more, it kind of behaved a little better. So the points that you're seeing on the right-hand side after that yellow circle, those are random. And what we observed was even those points kind of became slightly better, that it was, although buying in that period of stress, but it was performing much better. It was selling in the period of no stress. So which was pretty intuitive. So what's the takeaway? I think the takeaway would be that such kind of analysis, although I mean this is not very quantitative, but this can be the first step of doing some deep dive into all these machine learning, reinforcement learning kind of models. And you can definitely use these because what I've seen is that all these traders, portfolio managers, they tend to understand the charts and the pictures slightly better, and they're friendly towards it rather than if you show them the equations and all. So this can definitely be used to show to all these portfolio managers and traders and investors what's happening. And it definitely can answer some of your questions, like what are the drivers, whether it's stable or not, what's the impact of hyperparameters. And so far, I mean, in this example, what I showed was a very limited use case. It was just S&P 500, but it can be extended to multiple asset classes. It can be extended to other reinforcement learning models. What I showed was just the deep Q-learning, but it can definitely be extended to numbers of models, PPO and whatnot. I don't want to name them. It can also be extended to like different frequency of the data. We worked on daily data. It can be extended to different other frequencies. And you can plug in more number of features rather than just having volume, price. You can have sentiments, and you can have thousands of other features, fundamentals, and whatnot. So this is the final slide. I mean, something that think of it like a takeaway. So this was a paragraph that was from David Silver. He was the creator of AlphaGo, and I was listening to his podcast, and I just heard this paragraph. If you focus on those two red phrases, so what he mentioned was that AlphaGo discovered some of the strategies which were already discovered by us within which were already used by us within a few days of training. And it also came up with some successful variations, new strategies. Now, if you're using reinforcement learning, you are not mentioning or you are not forcing machine or algorithm to follow your rules or your ideas, there might be a chance that it can come up with some really good variations of this strategy, something that we have not known so far. And for that to happen, I think most important thing would be we need to trust. How we are going to build the trust by having these kind of interpretability approaches, understand all these algorithms slightly better, and who knows? I mean, we might have AlphaGo type of revolution in finance sometime in future.